Good morning, everyone. It's my pleasure to be here with you today. My name is Omar Mohammed Salah, and I'm an assistant professor in the Department of Engineering, Mathematics, and Physics in Zagazig University Faculty of Engineering. And I'm also working as an assistant on part-timer as an assistant professor as a part-timer in the Egyptian Chinese University, also teaching mathematics, statistics, and relevant courses. I would like to take you within the few seconds just through some courses that I've been really most fortunate to teach was the previous years. When I get back from the I came when I came back from the United States after I finished my PhD. I was in Tennessee. Then I've started to collect my background at that period in uh, to put some books in the relevant fields that I would like to teach in the university and also for students within the high school all the previous years. I had also the opportunity to teach my children in the middle school and in high school too. I have three of them, and also I'm also most fortunate to be able to teach in plenty of schools, either in Egypt, Case A, United States, and back again within these days to my students in Egypt. I have some publications I would like to show it to you. I have lecture notes in numerical mathematics and engineering. Actually, I made this book when I get back from the United States to back to 2010. Also, I made lecture notes in applied numerical methods. As you can see, statistics for engineering, decision making, analytical and numerical methods, few steps in computational mathematics. Those are all the courses that I've already joined, established the curriculum, and made those books. I thought to give you uh, some minutes about the contents of each book, but I once more thought it's better to show you some of my teaching skills. I have it as suitable teaching statement, but also I've preferred just to send it to you to the HR and not to represent it here. I will continue some of my experiences with you. I have few steps in computational mathematics. This also was a very nice book. Integration and analytic geometry, operational research, differential calculus, integration and its application, building system optimization theories, business mathematics for commercial. This is one of my favorite courses actually because it represents it's another type of audience that I had to work with. And it actually collect all the background that they have taken within the middle school and the high school all together in a very nice course. I've designed this course very well. Also for economy, this is about business mathematics. The financial mathematics also was really very nice. I had the opportunity within the last 2 years to teach students in the pharmaceutical schools for an introductory course about pharmaceutical mathematics, going through actually a lot about their course, about the course, which represent a huge background about starting from, as I told you before, starting from the middle school, the definitions, going through definitions of functions, the continuity, the limits, the derivative, how to differentiate, anti-derivative integration, then some of the algebra preliminaries they had to review, and so on, going up to statistics and even hypothesis testing in statistics. So it was really a very nice course. I'm talking about the pharmaceutical mathematics. Now, let me take you, I will talk a little bit about linear system of equations, which is one of the courses that I saw in the high school. And also, I would like to represent or to give just a lecture or introductory for describing data in statistics, which I've given a huge lecture this morning and yesterday for economics students. Let's start with the solutions for linear system of equations. Well, what can I say? Solution for linear system of equation, actually, it's really one of the most important fields of mathematics and one of the most rich and important topics in algebra that everyone in every pool should be familiar with. This is because it solves a lot of problems that will appear in general in STEM. No one, and I literally mean no one, can go to problem solving without knowing an idea about solution of equations or system of equations. We can start from. I'm sure everyone went through this, going through solution of one equation in one unknown to two equations in two unknowns, or even three equations in three unknowns. And some will go to more sophisticated systems of equations, as in engineering, to a system of 1,000 equation, 1,000 unknowns, or stuff like that, which actually the computer programs and the computer softwares do a lot in this problems, such problems. But at the time being, let's start with the most simple methods. As you can see in the PDF, I've prepared this part to you just to go through it step by step together. There are many ways for solving these equations, starting from the primitive method such as the graph method. See, for the problems with one unknown and one equation, we can simply solve this problem just by graph. It's one of the methods. Or in algebra, as I will show you just in a few seconds. If we have two equations in two unknowns, also we can try to solve them graphically, which is one of the very primitive methods in solving uh, 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 linear system of equation. I will speak about that. I will go also through elimination method. This chapter was prepared in order to represent the idea from the start, going to the more complicated or the much complicated methods of solution, like the Gauss-Jordan method, which is really, I'm a big fan of Gauss-Jordan method, especially if you try to solve it by your hand. It's really a very nice method. Let's start with the very simple method that we are talking about. Remark before going to the solutions that the number of equations must equal to the number of unknowns. The number of equations must equal to the number of unknowns or variables that you want to solve. For example, if you have one equation in one unknown, or if you have one unknown, one equation will be sufficient to get the value of that unknown. For example, if you have 2x minus 8 equals 0, we will be searching for the value of x that will oblique the left-hand side to equal to the right-hand side. How to do this? Simply, it's really very simple. All you have to do is just to move negative 8 from the left-hand side to the right-hand side. So you will have 2x equal 8. Then I will divide both sides on 2, which will give you x equal 4. So simply, the solution for this equation is going to be x, our solution set, will be x equal 4. Once you try to substitute, instead of x putting 4, you will have 8 minus 8, which is going to equal to 0. That's the left hand side equal to the right hand side. Okay, this is to start with the idea of an equation in one unknown. But what if we have two equations in two unknowns? If we have two equations in two unknowns, at this time, the equation that we are talking about is just a straight line equation. So the graphical method, it depends on just graphing one of these equations, which is going to be a straight line, since it has just only two unknowns, as we would see. And then I will grow or draw the other equation in front of it, at the same axis. The intersection point, it will represent the solution for these two equations in two unknowns. Here, as you can see, also, I've just spoke about the solution, the graphical solution, but as you can see here, it's just stating the fact that if you have two unknowns, then two equations will be sufficient. If you have three unknowns, three equations will be sufficient or will be required to have a unique solution for this system of equation. Once more, if we want to speak about the graphical solution of linear system of equations, which is really very simple, all we have to do, as you can see, if we have two equations like this, y plus 2x equal 4, 2y plus x equal 4, we will have to represent these two equations on the Cartesian coordinates. Say for y equal to x equal 4, I will have to get y in one side. So y will equal to negative 2x plus 4. The other one is going to be y will equal to negative x plus 4 divided by 2. Then I will try to draw this straight line as we saw previously. So simply all you have to do is to put x equal to 0 and get the value of y in the first equation. As I told you previously, the, if you would like to draw just one line, it's enough to have 2 points on this line. So for the first equation, which is y equal negative 2x plus 4, it's sufficient for you to have just only 2 points. How to get these 2 points? Just assume a suitable value of x, and get the value of y. I myself, I would prefer to put x equal to 0 and get the y-intercept. Then I will put y equal to 0 and get the value of the x-intercept. If we did that for the first equation, putting x equal to 0, it will develop y equal to y. I'm sorry, y equal to 4. So when you put x equal to 0 in the first equation, you will have y plus 0 equal 4. That's y equal 4. So I will go to x equal 0, then up to 4, and I will put the point which is the y-intercept. Same way like I will get the x-intercept by putting y equal to 0, that will develop x equal to 2. Then I will go to x equal to 2. I will take my ruler and draw the first line. In exactly the same manner, I will do 2y plus x equal 4, which is going to be the second line. Then I will get to the intersection point, getting the x coordinate and the y coordinate of this point, which will develop, okay, the point of intersection, which is going to be 4 over 3 and 4 over 3 on both x and y. I've tried to summarize these steps, these simple steps for you here. As you can see, the first step of the equation is to draw the equations are represented on the same axes with great accuracy. That's you have to be accurate about drawing your line and the points, and also you should be drawing or sketching these two lines in a suitable graph or axes. The second step, the point of intersection will represent the solution. Once you get the point of intersect, try to go to draw a small vertical line and a small horizontal line that will represent the intersection point. The elimination method is the second method that we should speak about, but I will stop at this amount about solving system of equations, and I would like to represent a little bit in statistics. So please, if you follow me, today's lecture was about describing data. As we spoke previously in the previous chapters, we've started our course, I'm sorry, about statistics, to go through the first chapter, which represent a suitable background about what we mean about statistics, the importance of statistics, various types of statistics, blah, 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 blah. When we interested in describing data, everyone should know that describing data, it's the soul of the descriptive statistics. As we spoke previously about this, that in general, if you remember, statistics in general, it consists, or you can classify it to three main parts. First of all, the descriptive statistics, then inferential statistics, then exploratory data analysis. If we spoke about the first one, and we have started this in the previous three lectures, okay, you will start with the descriptive statistics. And as we all know, we have three main stages in statistics: the planning stage for any statistical process, then the step which will go after that, which is the data collection stage, while I'm gonna get my data according to the observations that I'm interested in, either from lab or from field. Getting those data, then the next step is to go through analyzing the data that you have. We have started this issue since we started to spoke about frequency distribution. Once the spreadsheets are in your office, you will start the analysis by constructing frequency distributions for both types of data, either quantitative or qualitative data. Then, after establishing this frequency distributions, choosing the right chart to represent your data, either if you like the bar chart, the histodiagram, which is actually the two charts that I prefer to deal with. You will find that in the previous lectures recorded on my YouTube channel. We will start to describing that. Everyone by the end of this chapter should have the following items. First of all, you should be able to summarize qualitative data with frequency distribution tables. You should be able to choose the suitable measure that can be used with qualitative data. And we will talk about this in just a few minutes. Evaluating the various location measures for quantitative data. And we are going to study the mean, the median, the mid-range, the mode, and we will spoke about them and the relation connecting them all together, which is really very important and develop a lot to you. When we spoke and this will develop us to the goal number three, which is you should be able to have it and to understand it very well by the end of this lecture, how to evaluate the various dispersion measures, which is really a very important type of measure. And we will go through absolute measures in dispersion and also some relative measures like the coefficient of variation. Those are the main goals that you should be able to collect by the end of this lecture. If I want to start with you, you will have the first paragraph. I try to put this in a very short line, which states that describing data involves extracting information about the general distribution of data. This is really very important. Actually, in plenty of cases, you will have your observations collected for you. And I, as a decision maker, am just interested in just a small number that would represent this data. For example, if we are interested in the average income for a household within the county that we are living in. So all we have to do is to just collect some samples from our neighbors here and there and see if we could grab this information from the nice people that living around us. How much do you earn? How much your income within your monthly income? I will collect some numbers. Then what I'm searching for. I'm searching for just a small number to represent the average income. I need someone to come to my ears and say, hey, the average income is going to be 5,500, say, for example. But in order to do this, I will have to collect these data and then finding the average, either to find a mid-range or to find an arithmetic mean as a measure, or the median or the mode, as we can see in few minutes. This will take us to the importance of the central tendency measures. The central tendency measures, or the measures of location, serve you in getting this number. That will represent the sample that you collected about the average income for your neighborhood. Thank you very much for listening to me and giving me the opportunity to represent myself. I'm very happy to be with you. I will try to send this demo as fast as possible. Thank you. Appreciate that so much. Appreciate the time. Thank you. Enjoy your day. Thank you very much. Thank you. I will see you next session, inshallah. Thank you. Bye bye. Okay, I'll stop recording.